Hello everyone, welcome to my channel Chemistry is Fun. Now, since last few videos we are dealing in atomic structure part 3 which will be useful for NEET 2024. As a continuation to that, today I'll deal with some new concepts. We are summarizing the important points and along with that I will also help you to solve some numericals. So today we will deal with dual nature. Now see, we all know that light has a dual character. Dual character means what? Character means that it will behave like particle as well as like a wave. So dual character includes it will behave like a particle, that is one part, and sometimes it will also behave like waves. So you see two characters. So dual means two. So particle nature on one hand, dual nature includes particle nature and also wave nature. Similarly, de Broglie predicted that some small particles like electrons will also show both the properties, wave-like properties and particle character. So it will also show two types of characters, wave-like properties and particle character. Now, if it is having a wave-like property, there should be some wavelength associated with it, lambda, and that wavelength is given by lambda equal to h by mv. 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 This is very important. Here h is Planck's constant. H is a constant known as Planck's constant, Planck. Okay. So this one, H is a Planck's constant. And this wave nature was confirmed by Davison and Germer's experiment. And they have given some modified equations for the calculation of de Broglie wavelength. They have given some more equations which will help us to calculate lambda. Now see, on the basis of their experiments, we get that lambda equal to h by square root of 2em. Where E is the kinetic energy of the particle. Lambda equal to h by square root of 2em. Where what is E? E is kinetic energy of the particle. E is kinetic energy of the particle. I have a request for all of you students. Please subscribe to my channel because nowadays I am posting videos quite frequently and I am covering important topics for you. Numericals will be there, important questions will be there. It will definitely help you. I'll also try to explain the concepts. So please subscribe to my channel and share the channel as much as you can. Thank you very much. Next we will see is Heisenberg uncertainty principle. Heisenberg uncertainty principle. It states that it is impossible to measure simultaneously both the position and momentum of any microscopic particle with accuracy. Means when you are measuring the position, if position is correctly measured, momentum we cannot do. There will be some error in the measurement. So mathematically we can state this as delta x into delta p equal to h by 4 pi. Delta x into delta p equal to h by 4 pi. Here what is delta x? Uncertainty in position. Delta x is uncertainty in position, and delta p is uncertainty in momentum. Uncertainty in momentum. So from here we get the concept of probability of locating the electron. There is a probability that we can locate the electron in the space around the nucleus. Okay, so this is Heisenberg uncertainty principle. Now we will deal with some numericals based on the topics we have discussed earlier and discussed today. So let us see the first one. Calculate the velocity of an electron placed in the third orbit of hydrogen atom. Where it is? It is in the third orbit of hydrogen atom. Also calculate the number of revolutions per second that this electron makes around the nucleus. This is electron, electron, makes around the nucleus. Now see, first you have to calculate velocity. Where is it present? Third orbit of hydrogen atom. Now let us do this. Now formula we will use is mvr equal to nh by 2 pi. Mvr equal to nh by 2 pi. Okay. So here we need to know the r so that we can calculate velocity. So what will be v? V equal to, we have to shift m and r. V equal to nh by 2 pi mr. Here n we know, n will be 3 because third orbit they have given. H is known, 2 pi we know, m we know, r we don't know. We have to calculate r. So how to calculate r? Radius. Radius of third orbit will be equal to, we have to take r square into 0.529 into 10 to the power minus 8 to get centimeters. R is 3, n is 3, n we have to put 3. So r will be equal to what? 3 square into 0.529 into 10 to the power minus 8 centimeters. So 3 square will be 9. So 9 into 0.529 if we do, we will get around 4.761 into 10 to the power minus 8 centimeter. So this is the value of r we got. This r value we have to use it. This r value we put here. So what we get? V equal to n is 3. 3 into h, 6.624 into 10 to the power minus 27 divided by 2 pi. So 2 into 3.14 into 9.018 into 10 to the power minus 28. Mass you have to put 9.108 into 10 to the power minus 28 into R just now we got into 4.761 into 10 to the power minus 8. So now this is simple mathematical calculation, multiplication and division. I hope this all can do. On doing, final value we will get will be 0.729 into 10 to the power 8 centimeter per second. So this is the answer for B. Next is revolutions per second, number of revolutions per second. For that we need to calculate time taken for one revolution. So for the second part, T, time taken, T is equal to 2 pi R by V. Pi R by V. So number of revolutions will be we'll take the reciprocal 1 by 2 pi R by V. So V by 2 pi R. So now we will put the values. V we got 0.729 into 10 to the power 8 divided by 2 pi R, 2 into 3.14 into 4.761 into 10 to the power minus 8. So let us solve here. How much you get, just see. On solving what we are getting. You can also practice. You have to first to multiply 2 into 3.14 into 4.761. So we will get around 2.4 into 10 to the power 14 revolutions per second. Okay, I hope you all understood. Now one more we will do, calculate shortest and longest wavelength in hydrogen spectrum of Lyman series. Shortest and longest wavelength we have to find. Now see, here one small funda we have to use. That fundamental is that for Lyman series N1 equal to 1. Okay, and we are saying shortest wavelength. So when wavelength is shortest, frequency will be very high. Means energy will be very high. So for that N2 should be infinity. So for shortest wavelength, N1 equal to 1 and N2 should be equal to infinity, because then only you will get a high energy, then only we will get very high energy. High energy means E is equal to h nu, high frequency. So shortest wavelength. Now we will use this formula 1 by lambda equal to R into 1 by, it is 1 by n1 square minus 1 by n2 square. I have discussed this in the previous video of atomic structure. Please go through that. 1 by 1 square minus 1 by infinite square. So this will be equal to R. So lambda will be equal to reciprocal of R, that will be 1 by 109678. One by 109678. So calculate, on calculation, how much we get. Answer will be in centimeter here, and then we can convert it into angstrom. It will be around 9.117 into 10 to the power minus 6 centimeter. So this is the shortest wavelength. And if we want for the longest one, second part of the question was longest wavelength. So for the longest wavelength, n1 has to be 1 only, because it is, we are taking Lyman series. So for longest wavelength, second part, n2 should be equal to 2, because when n2 is equal to 2 and n1 equal to 1, energy will be very less. When energy is less, when it is going from n2 to n1, energy will be less, frequency will be less, wavelength will be very high. So that will be the longest wavelength. So putting these values in the same equation, we get 1 by lambda equal to R into 1 by 1 square minus 1 by 2 square. So 1 by 1 square is 1 by 1 minus 1 by 2 square is 1 by 4. So 1 by 1 minus 1 by 4, that will be 3 by 4. So it will be 3 by 4 R. So lambda will be equal to 4 by 3 R. 4 by 3 R. That is equal to 4 divided by 3 into, put the value of R, 109678. So on calculating what we will get, that will be in centimeter. So let us do it. So this is simple mathematical calculation, division and multiplication all can do. Please see how much you all are getting. In centimeters, it will be around 1215.7 into 10 to the power minus 8 centimeter. One two 15.7 into 10 to the power minus 8 centimeter. I hope students you all could understand the topic I discussed today and the numericals I discussed with you today. Thanks for watching my video. Please subscribe to my channel. Thanks for watching. Thank you all.